Hello children, welcome back to Chem is Try channel. My name is Mahante Shetter and this is the continuation of ICSE class 10 previous year questions 2020 section 2 part 2. So we have already done two videos which includes 2020 section 1 and as well as 2020 section 2 part 1. So this part 2 includes question numbers 5, 6, 7. Okay, let's start. So the question number 5, distinguish between the following pairs of compounds using a reagent as a chemical test. So means you have to use one reagent to distinguish these two. First one, calcium nitrate, zinc nitrate. In such questions you have to observe that which ion is common. Always there will be cation and anion. So here this is calcium is cation, nitrate is anion. So if you see in both the compounds, nitrate is common, anion is common. So cations you have to distinguish. So here we know in analytical chemistry chapter we learned about using ammonia solution as well as sodium hydroxide solution. Okay. So calcium and zinc, if you think, so there will be calcium plus 2 ion, zinc plus 2 ion. Calcium ion will not form any precipitate with ammonia solution, whereas zinc will form white precipitate with ammonia solution. So this you can use to distinguish calcium nitrate and zinc nitrate. But how do you write this? You can explain in sentences or you can also make two columns. Okay, so here you can write say 3 columns. Reagent, here zinc nitrate, then here calcium nitrate. Okay, like this. So reagent is what? Ammonia solution. Ammonia solution is, you can write that, or you can write NH4OH solution will form white precipitate, will form white precipitate. Calcium nitrate, no precipitate, no precipitate. Okay, this is how we have to write. Each question carries 1 mark. Ammonium sulfate crystals, sodium sulfate crystals. So if you observe here, again anion is common. So ammonium and sodium you have to distinguish. Since ammonium and sodium is not there in our analytical chemistry practical things, so ammonium ion is there, sodium ion is there. So this time what you have to use sodium hydroxide solution. Use sodium hydroxide. What happens, you know, in ammonia chapter, one of the method of preparing ammonia gas is react the salt of ammonia with sodium hydroxide solution or any alkali. So here what happens, ammonium sulfate reacts with sodium hydroxide, and when you heat it you will get ammonia gas evolved. Okay, along with that salt and water will be formed, but that's not important now. So here ammonium sulfate crystals with sodium hydroxide solution on heating give ammonia gas, whereas sodium sulfate crystals do not evolve any gas with sodium hydroxide. So this is how you distinguish between the two. Next one is magnesium chloride and magnesium nitrate. So magnesium is common, that is cation is common in this case, chloride and nitrate solution. So you know in practical chemistry you have anion detection. So for chloride and nitrate, there is one thing you can use. Take a solution, a reagent which has one of these two as common, but another one should form the precipitate. The ideal will be silver nitrate solution. So silver nitrate solution with chloride will give you silver chloride precipitate, which is white. But with silver nitrate it will not react at all because both are nitrates. So therefore you can distinguish magnesium chloride gives white precipitate with silver nitrate solution, whereas magnesium nitrate do not react. So that will be your distinguish. Calculate the percentage of fluorine, sodium and aluminium in sodium aluminum fluoride Na3Al F6 to the nearest whole number. So they will always give you the atomic mass of required elements. Sodium 23, aluminum 27, F19. So I think you know how to do this percentage composition. So first of all, for this molecule compound, you have to find the molecular weight Na3Al F6. So 3 atoms of sodium means sodium atomic number is 23, plus aluminium, only one atom is there, so just 27, plus 6 atoms of fluorine, so that is 19, 6 into 19. So if you do this 23 into final answer, you will get 210. Okay, so now we have to find percentage of fluorine is equal to, always percentage, how do you find percentage of any element is total mass of element divided by total mass of compound, right? So total mass of fluorine is 6 into 19, 6 into 19 if you do, you will get 114, divided by, and this will be percentage means 100, okay, divided by 210 into 100. So if you do this, you will get 54.28%. You can round it off approximately 54%. Okay, so then percentage of sodium, okay, sodium 23 into 3 you have to do, so you will get 69 by 210 into 100. So if you do this, you will get approximately 32.85%. Round it off, you will get around 33%. Yeah. Percentage of aluminium, if you do aluminum 27 by only one atom is there, 210 into 100. So if you do that, you will get 12.85% or approximately 13%. Okay, finally when you add all these three, it should be 100%. So 4, 3, 7 plus 3, 10, 5, 3, 8 plus 1, 9 plus 1, 10. So 100%. Okay, not there in syllabus, let's leave it. Leave this question. Okay, next question number 6. Identify the salts PQ are from the observations. Very important, most of the time practical based questions. Salt P has light bluish green color. Okay, usually remember blue or bluish color will be copper compounds. Okay, most of the time. On heating, it produces a black colored residue. Okay, salt P produces brisk effervescence with dilute HCl, and the gas evolved turns lime water milky, but no action with acidified potassium dichromate solution. So this line tells us that this should be carbon dioxide gas, because sulfur dioxide will not show, action with acidified potassium dichromate. It will show some action, but here it is carbon dioxide, means it should be carbonate, because you will get carbon dioxide from carbonate only. When any metal carbonate reacts with HCl, it will give you carbon dioxide. So since it is bluish green in color, I suspect copper, and residue formed is black in color, means the residue should be copper oxide. If you remember, copper oxide is black. So therefore you have the metal copper and cation copper and anion carbonate. So this compound should be copper carbonate. Copper carbonate. Please write the name, not the formula. Okay. Salt Q, white in color. So remember, white in color usually lead or zinc, sometimes calcium compounds will be there. Okay, but we'll narrow it down. On strong heating, it produces buff yellow residue and liberates reddish brown gas. Very nice. Reddish brown gas, you know, which is that reddish brown gas? Nitrogen dioxide. Buff yellow residue. So either it should be lead oxide, because zinc oxide will be yellow when it is hot, but after cooling it will become white. But lead oxide will remain yellow only. So if it is giving NO2, reddish brown gas, okay, and also if you see here, salt cube produces chalky white insoluble precipitate with excess ammonium hydroxide. Okay, even in excess ammonia it is not soluble, so then it should be lead only. So it should be lead nitrate. Lead nitrate. It cannot be zinc, because zinc will be soluble in excess ammonium hydroxide. So this is how we have to identify these things. Salt R is black in color. Okay. On reacting with concentrated HCl, it liberates a pungent greenish yellow gas, which turns moist starch avoided paper blue-black. So by this information, we know that this gas should be chlorine gas. Okay. So you're getting chlorine gas from HCl. So salt R. So if you want to get from HCl, if you want to get Cl2, hydrogen should be removed. Means this will be what? Oxidation. So then salt R should be an oxidizing agent. So that should be MnO2. MnO2 is black in color and it's an oxidizing agent. So it oxidizes HCl to chlorine gas. So this should be your manganese dioxide. Okay. Identify the substance underlined in each of the following. The electrode that increases in mass during the electro refining of silver. Whatever it is, the mass of the electrode which increases is always cathode, because always metal ion will come and deposit on the cathode. Okay, irrespective of what you're doing, electro refining or electrolysis, so it should be your cathode. The acid that is dehydrating as well as drying agent, this is concentrated sulfuric acid. It is important to write concentrated. The catalyst used to oxidize ammonia to nitric oxide. So this is catalytic oxidation of ammonia. The catalyst is platinum, the costliest element you can remember. Okay, copy and complete the following paragraph. Alkenes are a homologous series of unsaturated. Remember, alkanes are saturated. Alkenes, alkynes are unsaturated hydrocarbons characterized by the general formula. General formula of alkenes is CnH2n. Alkenes undergo addition reaction. Remember, alkenes, alkynes undergo addition, alkanes undergo substitution, and also undergo hydrogenation to form alkanes. Okay, so this is also addition only. When alkenes undergo hydrogenation, they will give alkanes. Means unsaturated, they will become saturated. Okay, this is question number 6. Next, question number 7. Write balanced chemical equation for the preparation of the given salts. Okay, this is not there in our syllabus now, so we'll leave this. For 2023 syllabus, it is not there. Name the following elements. An alkaline earth metal present in group 2 and period 3. Many students will have confusion, but remember, period number tells us the total number of shells. Group number will give us the valence electrons. So valence electrons are 2. 3 shells means there should be another 2 shells which have completely filled with electrons. So it should be 282, means total 12. So atomic number 12 is magnesium. So the element is magnesium. So please name it, not the symbol. A trivalent metal used to make light tools. Okay, trivalent, usually it will be aluminium. Okay, and metal means aluminium only. And light tools, so we learned duralumin, alloy and all, so aluminum is used. Monovalent non-metal present in fluorspar. Fluorspar formula is CaF2. Monovalent non-metal should be your fluorine. Last question, 4 marks. An aqueous solution of nickel 2 sulfate was electrolyzed using nickel electrodes, means both are active. Okay, nickel cathode, nickel anode, power supply, aqueous nickel 2 sulfate. What do you observe at the cathode and anode respectively? So as I already told you, cathode observation, increase in mass of the cathode, and anode will be decrease in mass. Name the cation that remains as a spectator ion. Spectator, in normal normally spectator means who is watching, not taking part, just like audience, spectators. So here the cation that remains as a spectator ion. You have to see in this what cations are possible. Obviously nickel 2 sulfate aqueous means nickel ion should be there, Ni plus 2, but it is not spectated, it is taking part in the reaction. So aqueous means there should be H plus. So H plus is not taking part in reaction, it's just remaining. So you just have to write here hydrogen ion. Hydrogen ion. Which equation for the reaction at the anode is correct? Okay, remember CNR POW. Okay, previously I told you. Anode means oxidation. Positive anode oxidation. Oxidation means what? Oil rig one more. Oxidation is loss of electrons. So here anode is nickel, so nickel should lose electrons. So when it will lose 2 electrons, okay, it will form Ni plus 2. But if you see here, this equation is not there, right? Many people think that, but it is there. How? You just send the electrons that side. Ni plus 2 plus 2 electrons. Okay, so if you find that, so that is the first option, so that is the correct answer. Okay, so this is the complete uh, discussion of 2020 question paper. So if you have any doubts, anything, please let me know in the comment section. Okay, we'll read well, prepare well. I will do such more videos in future. Take care. Bye bye.